Hello students, hope you are all fine. In the last video, I had discussed about important points and that is from physics chapter and from the lesson electricity. And today, in order to continue the topic, I will continue that same topic of electricity. In the last class, I had told you about the resistors in series and resistors in parallel. Today we will discuss about the next point, that is electric current. So electric current will be denoted by the capital letter I. So it is nothing but a stream of electrons moving through a conductor constitutes an electric current. You can mention it in the other way also. The flow of electrons through a conductor constitutes an electric current. So here I is equal to Q by T. You can represent it in the form of an equation. Here I is the electric current, Q is the charge, so and T is the time. So that means flow of charges in unit time. So that will be represented as I is equal to Q by T. Then we will go to the next point, that is resistivity. You should know what resistivity is. So it is an electrical resistance of a conductor of unit cross-sectional area and unit length. So this is the resistivity. And now this can be represented in the form of an equation, that is R is equal to rho into L by A. So R is the resistance here and rho is the resistivity, L is the length and A is the area of cross-section. So to calculate resistance and resistivity, we can use this formula. Now moving on to the next point, that is factors on which the resistance of a conductor depend. This also you should know from the point of view of examination. So there are some factors on which resistance depend. The first point is the resistance depends on its length, and resistance of a conductor depends on its area of cross section, and resistance of a conductor depends on the nature of its material. So now here this is what in the previous resistivity it is given. A is area of cross section, L is length. So that's what you will find here. Length is L, area of cross section is A. And then moving on to the next point, you should know the difference between an ammeter and voltmeter. So here ammeter is a device used to measure current. So how much current is passing through the circuit we can measure by using ammeter, and whereas voltmeter is a device used to measure the potential difference, that is the voltage in terms of voltage. It will be mentioned, and the device is voltmeter. The next point, the next difference is ammeter will be connected in series in an electric circuit. So in an electric circuit it should be connected in series itself, whereas voltmeter will be connected in parallel in electric circuit. And the next difference is ammeter, so it has a low resistance, whereas voltmeter shows high resistance here. And then moving on to the next point, that is the difference between the resistivity and resistance. You should know the difference between resistivity and resistance. So here to understand what resistivity and resistance, here you should know that resistivity of a material is the resistance of a wire of material of unit length and unit cross-sectional area, whereas resistance is the opposition to the flow of electric charges in a substance. So this is the difference between resistance and resistivity. And the next point is it is an intrinsic property. Resistivity is an intrinsic property, whereas resistance is an extrinsic property. And the next point is resistivity of a conductor is always same and is independent of its length or size, whereas resistance of a conductor depends on its length and size. And the next point is our unit of resistivity is ohm meter. You have to mention this value of resistivity in terms of ohm meter. There's a unit of resistivity, whereas resistance is a unit of resistance which will be expressed in terms of ohms. So this is the main difference between resistivity and resistance. Next we will pass on to fuse. You should know what fuse is. So fuse is a safety device which protects the electric circuit when unduly current flows through the circuit. So then that wire, the fuse, melts and breaks the circuit and stops the flow of current further. So it is made of an alloy of lead and tin, particularly having low melting point of 200 degrees Celsius. So it is the fuse. And then we will move on to the next point, that you should know that why is the series arrangement not used in domestic circuits. So it is very important that you should know about it. It is because if one electrical appliance stops working due to some defect, then all other appliances also stop working as the whole circuit is broken. Suppose at home, if any bulb or any other device, so it will, if it is out of condition and if it doesn't work, the other appliances also stop working because it will be in a series connection. Therefore, we will not use series arrangement for domestic circuits. Now, the next point is, what are the advantages of connecting electric devices in parallel with the battery instead of connecting them in series? So here the first point is, there is no division of voltage among the appliances when they are connected in parallel. And the next point is, the potential difference across each appliance is equal to the supplied voltage. And the third thing that you should know is, total effective resistance of a circuit can be reduced by connecting the electrical appliances in parallel. So these are the points that you should know. These are the advantages of connecting electric devices in parallel. And then moving on to the next point. So the question arises in our mind that why the coils of electric toaster and electric iron, they are made up of alloy only rather than pure metal. So these type of questions also will be asked in examination. So toasters and electric irons, they are all of alloy. Why we do not use pure iron like copper only and zinc itself? Because the reason is here, the resistivity of an alloy is higher than the pure metal. So resistivity is more. That is in the alloys than pure metal, and alloy does not melt readily and get deformed. And also the next point that you should know about it is, alloys have a low temperature coefficient of resistance. So these are the advantages why we use alloys for these electric toasters and irons rather than pure metal. And now I should know how to solve the problems also. And a simple problem that I am going to just show you here, and that is very important. You will give an idea how to solve the other problems. So suppose an electric current of 0.5 amperes is drawn by a filament of an electric bulb for 10 minutes. So if a bulb burns for 10 minutes and which draws the current of 0.5 amperes, then you have to find the amount of electric charge that flow through the circuit. So how much of electric charges flow through the circuit? So first of all, you should know what is given in the question. So here current I is 0.5 amperes, time is 10 minutes, and these 10 minutes should be converted into seconds. 10 minutes. So that is 10 into 60, that's equal to 600 seconds. And then you have to find charges. So that is Q. Using the formula, Q is equal to I into T. So you have to use this formula, I into T, and substitute the values of I and T here. So that is Q is equal to 0.5 into 600. So if you multiply, you will get the value as 300. That is unit C is coulombs. That is the unit of charge, 300 coulombs. So in this manner, first you have to write what is given and then use the formula and solve it. So in this manner you have to solve the problems. And the next problem is how much work is done in moving a charge of 2 coulombs across 2 points having a potential difference of 12 volts. So here also let us write the amount of charge, that is Q. Charge will be denoted by the letter Q, that flows between the points of electric potential difference, that is V, is equal to 12 volts. 12 volts is the potential difference, and the charge is 2 coulombs, and the amount of work done will be denoted by letter W. That is that work is done in moving the charge. The formula that we have to use is W is equal to V into Q. So here V is 12 volts and Q is 2 coulombs. 12 into 2 we get 24. That is W work done is 24 joules. So joule is a unit of work. So therefore W is equal to 24 joules. So in this manner you have to solve different problems. And here I will stop, and the next how to draw the diagrams and all I will just solve in the next one. In the next video I will just tell you about it. And we will move on to the next problem. So here there are two parts in this question. The first is how much current will an electric bulb draw when a 220 volt source if the resistance of the bulb filament is 1200 ohms. And next part of the question is how much current will an electric heater coil draw from 220 volt source if the resistance of the heater coil is 100 ohms. So let's try to solve these problems also. So what is given in the first one, so that we have to write. So it is given that voltage is equal to 220 volts and resistance is 1200 ohms. And we have to use the equation I is equal to V by R, because in the question it is asked that how much current an electric bulb draw. So I is electric current, so equation we have to use is I is equal to V by R. So here V is 220 volts divided by 1200. If we divide, we will get an answer 0.18 amperes. So depending upon the question, we have to use different equations. And moving on to the next part of the question, that is how much current an electric heater draw. So here also we have to find I from a source 220 volts, that V is equal to 20, and resistance R is 100 ohms. So V is given, R is given, and we have to find I. So same formula we have to use here also, that is I is equal to V by R. So that is equal to 220 volts by 100 ohms, that is equal to 2.2 amperes. So this device, the second device, the electric heater, draws the current of 2.2 amperes, whereas in the first one electric bulb draws 0.18 amperes of current. So here these problems you have to just work out, you have to practice makes you perfect. So next I will so take you to the next point, that is the SI units. And that is the important definitions also along with that. So here the important definitions and also units I am going to tell you. And first of all, let us take up 1 ampere. What do you mean by 1 ampere? So 1 ampere is constituted by the flow of 1 coulomb of charge per second. So that's called as 1 ampere. So 1 A is equal to 1 C by 1 S. So here A is ampere, C is coulomb, and S is second. So that is the definition for 1 ampere. Next, let us move on to 1 coulomb. How much is 1 coulomb equal to? How many electrons? So that is 6 into 10 to the power of 18 electrons constitute 1 coulomb. And next we will move on to the voltage. So 1 volt is a potential difference between 2 points in electric current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. So that's called as 1 volt. So 1 V is equal to 1 J by 1 coulomb, that is 1 J by 1 C. Now let's move on to the next point, that is 1 ohm. So there is a symbol written 1 ohm. 1 ohm is if the potential difference across two ends of the conductor is 1 volt, the current through it is 1 ampere. So here 1 ohm is equal to 1 volt by 1 ampere. So this is the definition that you should know about the 1 ohm definition. And what do you mean by 1 watt? So 1 watt is the power consumed by a device that carries 1 ampere of current when operated at the potential difference of 1 volt. So it can be written in this form, that is 1 watt is equal to 1 volt into 1 ampere. And then what do you mean by 1 kilowatt? So here kilo means 1000. So here 1 kilowatt is equal to 1000 watts. And there is a commercial unit of electric current, that is energy, that is 1 kilowatt hour that we use in electricity. How many units we are using, how many units of current we are consuming. So for all that it will be mentioned in terms of kilowatt hour. So here 1 kilowatt hour is 1000 watts into 3600 seconds. So hour will be converted in terms of seconds. So that is 60 into 60, that is 3600 seconds. If you multiply, you will get this value, that is 3.6 into 10 to the power of 6 joules. So 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. Now we will just discuss about the important SI units. To start with, first of all, electric current, that is I, its equation is Q by T. So the SI unit of electric current is ampere. It is ampere. It is denoted by the letter A. Next is electric charge. It is denoted by the letter Q. It will be calculated by multiplying I into T, that is current into time. Its SI unit is Coulomb. And then from this we can calculate time also. Time is equal to Q by I and SI unit is seconds. Next is potential difference, which will be denoted by the letter V. So V is equal to W by Q, and the SI unit of voltage will be V. And then work done, that will be denoted by W. Its SI unit is joule. Then coming to the next point, that is resistance. SI unit of resistance is ohms. This is the symbol that we use to denote ohms. And then resistivity, and symbol for this is rho. So it is like P that we denote, and that is SI unit for this is ohm meter. Then we come back to the next point, that is electric power. SI unit of electric power is watt. And the next point is electric energy. So electrical energy, the SI unit to denote this is watt hour, W, that is WH. Then commercial unit of electrical energy. So the SI unit of commercial unit of electric energy is kilowatt hour, which we just discussed before this. So now in the next video I will come back with the next topic. Thank you, children.